Acceleration in SHM means here we have to do acceleration. What the acceleration formula means, I can write acceleration as dv by dt, differentiation of velocity with respect to time. Velocity formula, what we have derived in our last class is a omega into cos omega t. So velocity is a omega cos omega t means a equal to d by dt of a omega into cos omega t. So from here, what should I write? A is equal to a omega constant. A is constant, omega is constant. I moved it outside. D by dt of cos omega t. Remember, differentiation of cos is minus sine. Differentiation of cos is minus sine. So A is equal to a omega into minus. Here cos omega t, omega is constant inside. Omega will come out minus sine omega t. So differentiation of cos omega t. What is differentiation of cos omega t, beta? Minus omega t into sine omega t, because we are differentiating with respect to time. So from this expression, we can write here small a is equal to minus here omega into what we got just now. Here we written it as omega into omega will become omega square. Omega square. What is the expression we got, beta? Omega square a sine omega t. This is the expression what we got. Now observe carefully here. What is a sine omega t? A sine omega t is nothing but displacement. So as a sine omega t is nothing but displacement, I can write a equal to minus omega square y. So this is the expression for acceleration. Observe carefully. Now our work starts with this one only, beta. A is equal to minus omega square y. We got some expression for acceleration. Acceleration. We have to analyze this expression clearly now. Let me take next page here. A is equal to, I got minus omega square y. Here omega is constant because we told periodic. Periodic means it repeats in regular intervals of time. Periodic means omega is constant. The body repeats its motion in regular intervals of time. So omega is constant means, what should I write here? A is proportional to minus y. A is proportional to minus y. So here, this is the condition for SHM. SHM says that condition for SHM is now, condition for SHM is satisfied. So condition for SHM is, it must be periodic, it must be oscillatory, and also it must be acceleration directly proportional displacement, but opposite in direction. So acceleration, direct displacement, both are opposite. A negative sign indicates opposite direction. So from this information, I can write A is equal to minus omega square y is called as equation of SHM. I can call this as equation of SHM. Here omega is constant here, and this is called as equation of SHM. A is minus omega square y is called equation of SHM. Now let us observe important point here. At mean position and at extreme position, what will happen at mean position? What will happen at extreme position? We have to find out. Mean position means displacement is zero. So displacement is zero means acceleration will become minimum. Its value is zero because y is zero at mean position. Extreme position means y is equal to a, capital A. Displacement is capital A. So at extreme position, I can write A is equal to minus omega square capital A. The negative sign indicates only the direction. It is not related to magnitude. So here, you don't worry that negative sign is there. No, sir. Negative is less than 0. No, sir. Why you wrote that as maximum? Why you are taking this as maximum? And minus sign is there. We are taking maximum, and 0 is there minimum. I know 0 is greater than negative sign. I'm not discussing about your negative sign. Negative sign indicates the direction here. So no way connected with negative sign here. So just the magnitude is maximum omega square A. So whenever they told mean position, we know y is equal to 0. Extreme position means we know y equal to a amplitude. Substituting in the above formula, we got these two things. This is the acceleration information. Now, let us observe carefully now. So, what are the things we got? First, we got y is equal to a sine omega t. This is the displacement equation we have taken. So, it is a sine function means how to plot the graph here. Y and time. Y and time, I am plotting the graph. Time is taken on x-axis. Displacement y is taken on y-axis. Y is taken. Then we know y equal to a sine omega t. T equal to 0 means sine 0. Like that, substitute the t equal to 0, t equal to t by 4, t equal to t by 2. Like that is a sine function. Mathematically, we can write sine function means in this way. This is a sine function, sinusoidal wave, sinusoidal wave. Here, observe carefully. This point is 0. This point is 0. Here, the maximum amplitude from here to here, the maximum amplitude I can write as A. So here the time period is t by 4. Here time period is t by 4. Here time period is what we can write t by 2 off. Here again time period is I can write 3t by 4. And here again I can write time period as t. Time period I can write as t. T is the time period. Time taken to make one complete oscillation is called as time period. Time taken to complete one oscillation is called time period. Suppose this is the mean position starting from mean. So observe carefully here. This is the mean position. Mean to extreme, extreme to mean, mean to another extreme to mean. This is one oscillation. For one oscillation, time taken is called as time period. So like that I can write now. This is the displacement time graph. This is the displacement time graph we plotted. Let us see now velocity time graph. So what is the velocity time graph formula means? First of all, v is equal to I can write a omega into cos omega t. Here cos function, and cos is positive here. Cos is positive here. Observe carefully here. Cos is positive. So positive means we have to plot according to the graphs from maths. Positive cos function means we have to start like that. So here at 0 it starts here. Velocity is taken on y-axis, time on x-axis. So where it meets, that point is now, this point we can call it as t by 4. And this point is t by 2. And this point here it touches is 3t by 4. And again it comes here like that. And there's a maximum here. This is capital T. So like that we have to plot the graph for velocity time. It's a cos function. Displacement time, sine function. So if you put here t equal to 0, how you handle like this, sir? Substitute t equal to 0. T equal to 0 means we are getting a omega because cos 0, 1, a omega. A omega is the maximum value. This is the point where we are calling the maximum value. It is a omega. So a omega starting from maximum. That's the graph we got in this curve like this. Here, see, observe here. T equal to 0, you substitute t equal to 0. If you substitute t equal to 0 means sine 0, 0, total displacement 0. That means it has to start from 0. So starting from 0, because sine function t equal to 0, sine 0, 0. But here t equal to 0, t equal to 0 means cos 0 is 1, cos 0 is 1. 1 means it has value. V value is not 0. If V value is 0, we can start from here. But V value is a omega at t equal to 0. Just observe. T equal to 0, suppose you substituted here. I will get V is equal to a omega into cos 0. Cos 0 is 1. V equal to a omega. So a omega means we can't start from 0. We can't start from origin. For that purpose, we started the graph from the positive y-axis, the positive y-axis value, that is a omega. And from there we have plotted the graph here. I hope you are clear with the velocity time graph. Now let us see the acceleration time graph. So now our target is acceleration time graph. For that, was the formula? A is equal to minus omega square A sine omega t. This is my formula I have. Suppose for example, if I put here t equal to 0, what will happen, beta? T equal to 0, A equal to 0, T equal to 0, A equal to 0. No doubt. Why t equal to 0 means sine 0. Sine 0 is 0. But here after t equal to 0, okay, fine. T equal to 0 means we have to start the graph. From where shall we start the graph means our answer is from origin. Because acceleration we got 0. We have to start from origin. That we understood. That point we understood. Now acceleration is in this direction. T is in this direction. From origin only we have to start. That is very clear because t equal to 0, A equal to 0. We are happy. So one point, whenever there is sine term, remember there is sine term, we have to start from origin. Like that you can remember, no problem at all. If cos term is there, sine theta from origin, cos theta from positive y-axis. Simple, I will give one information once. Whenever beta, general information I am giving you, there is some sine theta means sine theta plus sine theta is there, you start from here. And minus sine theta is there, minus sine theta is there, you start from down. Minus sine theta from down. Okay. And like that, whenever plus cos theta is there, plus cos theta, you start from above. And minus cos theta is there, you start from below. Like that you can remember. Okay, better, no problem. Like this also you can remember. Plus cos theta, we can start from here. Minus cos theta, we can start from here. Like that we can discuss. I hope you are clear with these things. Plus cos means from positive y-axis, minus cos from means negative y-axis. And sine means always. Sine means where should we start? Sine means you have to start from origin. Plus sign above origin, like that you have to move. And minus sign below origin. Like that you can remember. I'm saying it's not exactly how we got that one means theoretically. That means just have given the basic information. But mathematically, we have to discuss that. Fine. A equal to minus omega square A sin omega t. Suppose here t is equal to actually sin omega t. Observe carefully, I am writing one point here. Sin omega t we wrote. Omega is nothing but 2 pi by capital T. And t is there. This is the function what we have. Sin omega t. Omega means 2 pi by capital T. Now suppose small t is there. Small t is t by 4. Small t is t by 4. Suppose I am taking small t as t by 4. Now tt will be cancelled. 2 will be cancelled. 4 will become 2 now. Sin pi by 2. I got it as sin pi by 2. Sin 90 value is 1. So if I take now sin 90 as 1, here pi by 2, here 1 I got. So here this is 1 means here what I am observing above, you observe here. Sin at t by 4, I got here minus value, minus, this became 1. If I put here small t as t by 4, small t as t by 4, small t as t by 4, this value became 1. This value became 1 means, what is the acceleration? A equal to minus omega square A. So it is from where we have to plot this one. Minus means negative. Negative it is there. Negative is there means you have to draw the graph from down. This is the point. Minus omega square A. Minus omega square A point. It is negative. So we plot the graph from down. So this is 0. We know this is the origin point. And this point is what we call as t by 4. As usual, this point is t by 2. And this point 3t by 4. And this point time period t. So you have to understand, very simple, plus sign is there, the graph will start from above, minus sign is there below. Here plus cos is there, above origin, plus, because A omega cos always starts from here. Suppose minus cos means we have to start down. We'll see those things also later. I hope till here all the things are clear. How we got all these 3 points for velocity time. This is the velocity time, displacement time, and acceleration time. Now observe here. Here, suppose I am discussing about displacement, velocity, and acceleration. So what is the phase difference? Phase means what? Phase means here y equal to what we have here, A sin omega t. Velocity means what we got, A omega cos omega t. Acceleration minus omega square a sine omega t. So what is the difference in angles here? Difference in angles. What is the difference here? Sine function is there, cos function is there. What is the difference here? 90. Sine 90 plus theta is cos theta. So the 90 is the phase difference here. Phase difference is pi 2. Again, velocity and acceleration. Velocity here, cos and sine. Cos and sine, again, phase difference is 90. Phase difference between the displacement and velocity is 90. And velocity and acceleration also 90. But if you observe the displacement and acceleration, this is a plus sign. Displacement is positive sign. Here negative sign. Positive and negative sign means sine 180 plus theta. If you take, what is sine 180 plus theta? Sine 180 plus theta is minus sine theta. So here the phase difference what we have here is pi. So between displacement and acceleration, phase difference is angle difference. Phase means it is simple language, angle. Simple language we can say angle. Or what we can write definition point of view means, if you use the term phase, what is phase? Which gives the information about position and direction at any instant. Position, direction of the particle at any instant is called as phase. It gives the information about position and direction. Or simple language, angle. So angle difference between displacement and velocity means pi by 2. Between velocity and acceleration, pi by 2. Between displacement and acceleration, pi. Like that, we can give the information here. I hope you are clear with this idea, beta. How I handle the situation, I think you are understanding this one. Next, let us see here. We'll observe one more application here. What is the displacement in acceleration and time? Whenever we discussed here, A is equal to, just now we told it as minus omega square y. This is called also as what? Equation of SHM. We are writing it as equation of SHM. Now observe, acceleration can be written as differentiation of velocity with respect to time, or I can also write double differentiation of displacement with respect to time. Double differentiation of displacement with respect to time. Acceleration we can write differentiation of velocity with respect to time, or double differentiation of velocity with respect to time. Double differentiation means if you differentiate first displacement, we got differentiate with respect to time, we got velocity. Velocity differentiated, we got acceleration. Or directly we can say double differentiation of displacement is called as acceleration. Double differentiation of displacement is called as acceleration. From that information, I can represent A as d square y by dt square. Observe carefully. In the place of A, I am putting now d square y by dt square is equal to, what shall I write? Minus omega square y. Minus omega square y. So d square y by dt square is equal to minus omega square y. Happy we are regarding this equation. Further, I can write this equation as, just now I wrote d square y by dt square is equal to minus omega square y. I can write this equation as d square y by dt square plus omega square y is equal to 0. And now this equation I am calling it as differential equation of SHM. Differential equation of SHM. It is called as differential equation of SHM. I hope you are clear with how to handle differential equation of SHM. So previous one, what we have written now, final conclusions I'll give here. Acceleration means I can write it as equation of SHM is omega square y. This is a linear equation of SHM, or we can simply write equation of SHM. A is equal to minus omega square y. Omega is constant, omega is angular frequency. Or we can write d square y by dt square is equal to minus omega square y. Or I can also write this one only, the same equation. I am writing it as plus omega square y is equal to 0. And I am calling this as differential equation of SHM. differential equation of SHM. After this, now after observing these two things, they got one idea about what is angular SHM. The question arised, what is angular SHM? So angular SHM means, observe carefully beta here. So angular, our target is now angular SHM. How to handle this angular SHM concept means, in linear we got general equation, what we got, A equal to omega square y. A is analogous to alpha in rotatory motion, acceleration in translatory, alpha is in rotatory, angular acceleration. And displacement is analogous to angular displacement. Displacement is analogous to angular displacement. Now I can write it as alpha is equal to minus omega square theta. Now this is called as angular SHM equation. Angular SHM equation. So linear means A equal to minus omega square. Here angular. So linear acceleration, angular acceleration. Linear displacement, angular displacement. Simply we can understand like that. So now what we can conclude now, the finally we can give some important points now. Let us observe here. So now what I want to give here is conclusions. That is about two things. A is equal to minus omega square y. A is equal to minus omega square y. A can be written as what? D square y by dt square. So I can write this as d square y by dt square is equal to minus omega square y. Fine. And again I have written here alpha. Alpha is equal to minus omega square y. Alpha is nothing but d square theta by dt square. D square theta by dt square. Double differentiation of angular displacement. Here remember, you must not write y here. You have to write here theta. Displacement analogous to angular displacement. Here now I can write minus omega square theta. Observe carefully. Now A equal to minus omega square y. D square y by dt square is minus omega square y. Alpha is minus omega square theta. D square theta by dt square is minus omega square theta. These are the equations we got. Now we call this as equation of SHM. Equation of SHM. This is differential equation of SHM. Differential equation of SHM. Next it is now, next one is angular equation of angular SHM. Equation of angular SHM. We are calling it as angular SHM. Next, last one we can call it as differential equation. Differential equation. Differential equation of angular SHM. Differential equation of angular SHM. Like that, we can discuss the SHM and angular SHM also. I hope you are clear with these applications what we discussed. So first step what we discussed in today's class about acceleration, we are discussing about the derivation. We got acceleration value. What is the acceleration value we got here? We got minus omega square y or minus omega square a sin omega t. After that, what we did here, we discussed the things of displacement, velocity and acceleration time graphs. After that, we discussed about the velocity and displacement phase differences. Displacement, velocity, acceleration, phase differences, how they are differ with the angles. Then we discussed about finally the differential equations of SHM and equation of SHM, equation of angular SHM, differential equation of angular SHM. These are the topics what we discussed in today's class. I hope you are clear with these topics better.